This is Solutions 4, where we're going to be talking about making solutions through a number of different means. And in order to understand how to make solutions, you have to be aware of a very specific piece of glassware called a volumetric flask. Volumetric flasks are designed for making solutions. They have a single marking on them that allows you to know a very precise volume of solution. And they come in all different sizes. Since they only have one marking on them, you need several different sizes of them if you want different volumes of solution. So here you can see on the screen, we have a 100 milliliter volumetric flask, a 50 milliliter, and a 25 milliliter. Of course, they go bigger. Here's a full liter. I've seen 2 liters up to 5 liter volumetric flasks, and potentially they even come bigger. And then, of course, microchemistry, you can go all the way down to volumetric flasks that are only 1 milliliter. So huge range of different flasks for making solutions. There are 2 primary ways to go about making a solution. One is to dissolve a solid in a solid solute, in a solvent. Of course, we could also dissolve a liquid solute in a solvent, but these are kind of standard methods for doing this. So in order to make a solution by dissolving a solid solute in a solvent, you're going to first weigh out a desired amount of solute. So you're going to have to figure out how many moles you want in that particular container. You're going to have to do the conversion from moles to grams, and then you're going to weigh that material out on a balance. Once you've weighed it out, often you'll want to use a funnel. Sometimes you can pour it directly into the volumetric flask. Sometimes you'll have to mix it with a little bit of water in a beaker first if the crystals are too big to fit in the narrow neck of the flask. Dissolve it in a little beaker of water before you transfer it to the volumetric flask. Once you transfer it to the volumetric flask, you're going to want to make sure you rinse all of the sides down. If your solvent is water, which it typically is, you can just use a simple wash bottle, spray the sides down with a little bit of water, and then you're going to want to swirl the flask around until that solid dissolves. Once you do that, that little marking that you can see across the neck is the volumetric mark on this particular flask. All flasks have that mark. Some of them are higher up on the neck, some are lower on the neck, but that is the volume marker for that particular size flask. So you're going to want to fill it up a larger source of water till you get up into the neck, and then you'll use that wash bottle to finish till you get the meniscus of your curved liquid right the bottom of the meniscus right there at that volumetric mark. Then you're going to want to cap it, cover it with foam, and you want to invert the flask a few times in order to get that solution mixed. And that's how you would go about making a solution from a solid. The second way we go about making solutions, or the second primary way anyway, is to dilute a more concentrated solution. You can think about all of the concentrated drink mixers that are available. You take a little bit of this concentrate, you put it in your water bottle, and then fill your water bottle up. And the amount of concentrate that's specified on those containers is designed from a dilution equation at some point. So what you're going to do is start with your concentrated solution that's there all the way on the left, and you're going to figure out how much of it you want to make your diluted solution. And there's an equation for that we will go over in a moment. So you're going to measure out a very specific quantity based on that equation. Here we have a picture of a graduated cylinder. Often you'll do that using what's called a pipette, which is a narrow piece of glass that you're going to apply suction to a particular quantity of that concentrate out, and then transfer it to your dilute solution container. So that diluted solution container there in the first picture is empty. We're going to transfer that specified amount of the concentrated solution into that new volumetric flask. Then we're going to fill that volumetric flask again with a source of solvent until we get to the neck. And then you're going to want to use a wash bottle to slowly add solvent until you get to the volumetric mark. Again, you're going to cap it and invert it. So we have dissolving a solid in a solvent, and we have diluting a more concentrated solution, both of them using volumetric flasks to make solutions. Let's talk about the dilution equation, how you figure out how much of that concentrate to make a new solution that you want. The dilution equation is a fairly important thing here in chemistry. A few years back, I went to a seminar at the campus of Kansas State in Olathe, and there was a company that was renting lab space out, and we toured their lab space facility. They kind of told us a little bit what they did. And the manager of that lab space told us at the time that when he hired new lab techs, the first thing he would do is sit them down with all things of a worksheet on how to make dilutions, because one of the things the lab techs would need to be able to do is make dilutions of solutions. So the dilution equation looks like this. It's M1 V1 equals M2 V2, or the molarity of your more concentrated solution times the volume of your concentrated solution. That's that small volume we put in the bottom of the flask, is equal to the molarity of your concentrated solution, or sorry, your dilute solution. That's M2, which we would expect to be less because you've diluted it, and a much larger volume, because then we're going to then fill that flask all the way up to that volumetric mark. And so M1 V1 equals M2 V2. Molarity, of course, is going to be in molarity, moles per liter. And since there's a volume on both sides, you don't actually have to change your volume to liters. As long as both V1 and V2 are in the same units, you can use any volume measurement you want. So here's an example of how you go about this. We have a concentrated solution of sulfuric acid at 2.5 molar. And we want to know how much of that concentrate, how much do we take out of that first container to put into the new container that we're then going to fill up to 500 milliliters, so that we reduce from a 2.5 molar solution to a 4 molar solution. So M1 V1 equals M2 V2. You're going to set up your M1, which is 2.5 molar. We're trying to figure out how much of that concentrated solution we're going to use to produce a 0.4 molar solution that is 500 milliliters. So in order to solve for V1, we're going to divide both sides by that 2.5 molar, and you'll notice the 2.5 molar cancels. On the other side of your equation, molarity cancels, and the units you're left with are milliliters. So you're going to multiply 0.4 times 500. We're going to divide that by 2.5. And you're going to find out that it's going to take 80 milliliters of the concentrated solution. A follow-up question you might ask to this is then, how much water did you have to add? Well, we want a 500 milliliter solution. We used 80 milliliters of concentrate. Then 420 milliliters of water would get us to that 500 milliliter solution. So that's how the dilution equation works. So what I'm going to do is give you some practice problems working through that. So here are 3. So you can video, you can take a screenshot of this and set it aside for later, and then maybe skip through. But I'm going to put this up here in just a second. So go ahead and pause the video, work through these problems. When you get them all done, turn the video back on. So I'm just going to put the answers here real quick. Again, this is just simple M1 V1 equals M2 V2 questions. For the second one, we have this answer. If you did stop the video and work the questions out, you might be saying, hey, wait a minute. And maybe you got this answer. But just like I talked about in that last slide just a little bit, it's not asking how much solution, it's asking how much water you're going to add. So this is telling you that you've added a certain amount of concentrate. It's telling you what the volume of your new solution is. You have to subtract that concentrate from the volume of the new solution to figure out how much water you will have added here. And then the last one, M1 V1 equals M2 V2. In this case, we are trying to figure out what the new concentration is going to be if we dilute 63 milliliters of this solution into a 2-liter container. And so your new molarity should be 0.032 molar. So real quick, just as a review of really kind of everything that's gone through in this topic, we have all of our concentration equations there. We have our dilution equation there on the bottom left. That is the solubility relationship. And so all of those are the kind of things you need to be aware of as you're working through your homework and through problems related to solubility. I've set up another set of practice problems. Again, these are mainly dealing with the concentration equations that we just showed. So this is kind of a review on the topic. So again, you might video, work through these problems, and then when you turn it back on, I'll have the answer key set up. So here's a molality problem. There's your answer. You can check that real quick. And then here's the work for solving that problem. Mole fraction problem down here in the second one. It's listed as number 5, the mole fraction of H2O. Again, you're going to have to find the moles of all of those things. You want the moles of water on top, the total moles of the mixture on the bottom. Last one is a molarity problem. Molarity equals moles per liter. Again, you're given grams of solute, so you first have to convert that to moles and then divide the moles by the number of liters in the solution. So you have to convert that milliliters to liters. So that concludes solutions. And so we'll leave it at that.